So, uh, thank you for joining us in this session where we delve into the fascinating world of remote sensing and crop monitoring. My name is Mohamed Lamin Gindo. I am an assistant professor at Dhaka University of Science and Technology, and I'm going to be the host for this session. So, in today's presentation, we'll explore how sensing technologies such as satellite imagery and aerial drones provide us with detailed and up-to-date information about crop health, growth patterns, and yield estimation. This insight empower farmers to make informed decisions and take timely actions to enhance agricultural productivity. So, sensing technologies are changing farming for the better. So they give us a new way to monitor and to understand and control how we grow crops instead of guessing how we do it. So right now we can use satellite and drones to get a clear and real-time information about our fields. So basically, these technologies help us see how our crops are doing and predict how much we'll harvest more accurately. So this is not only makes farming more efficient, but uh, it will help to better understand and to better care our environment. As we go through this presentation, you will see how these changes are making farming smarter and more sustainable. Let's start by talking about satellite image. So, satellite is just like a big camera in space that take pictures of the Earth from way up high. These pictures help us see our fields and crops, and from a completely different perspective. So it's like having a bird eye view of everything. So it's a very powerful device which have to do a lot of things, not only in agriculture, but they can use it for different aspects, such as weather forecasting and many other applications. So satellite image is giving us a high resolution image. So the pictures satellite take are super details. So we can zoom in and see things things up close. So the high resolution imagery give us a very accurate data. It's like having a super detailed map of our farms, which is incredibly useful for farmers. And the amazing things with satellite are it's like our eyes, as I said, inside the sky, and they can keep an eye on like a really big area, so all the time. And this means that we can watch over large farms in fields 24 hours. It's a bit like having a guardian angel for our crops, making sure that these doing well. So the advantages of satellite is that they provide image with different set of band frequencies, and we can obtain the data at no cost compared to drone where you have to purchase the instrument. So for unmanned aerial vehicles, so which is UAV, is also called drones, and they have become a valuable tools for modern farming practices. So they offer advantages of rapid data collection. They can cover extensive agricultural areas in relatively short time, and this efficiency not only save time but also reduce the cost associated with manual labor and equipment, making them a cost-effective solution. So we have a many application of agriculture using drones and satellite. So one of the application is crop monitoring crop health. Okay, so first things, we use these tools to check how our plants are doing. So monitoring crop health using drone or satellite is a rapidly growing field. with the potential to revolutionize agriculture by capturing high resolution images of crops. Uh, this technology can provide farmers with some high and valuable insight into the health of their plants, and this allowed them to make informed decision about irrigation, fertilization, or pest control. So it's a very powerful way to control our crops. Again, at the picture on left, we can see that the image we get from drones. So as I said, drones offer several advantages for crop health monitoring. So for example, like compared to satellite, drone can fly at low altitude, providing high resolution images that can be used to identify individuals, plants, and assess their health. So basically, drones can also be equipped by with a variety of sensors. So those sensors can be like multispectral sensors and hyperspectral sensors. So they are very powerful sensors which are not visible to the human eyes, and this data can be used to identify nutrient deficiencies and disease and pests. So combining those sensors with drone can have a lot of advantages. So for the satellite image, as you can see at your right, and they can also help to collect data. But the difference with drones, probably drones, is very difficult to be at the farm, at the fields, like every day or every hours. But satellite, they can take data on a more regular basis than drones, providing farmers with continuous streams of information about their crops. Another type of application for drone and satellite in agriculture is tracking growth patterns. So in order to explain this issue, so we just like to have to think like just like you and me when we were young, we was like measuring our height to see if we grow or not. So it seemed like the crop also is like we do the same for the crop. I mean, it's like a growth chart for plants. So every time you have to check if the plant is growing very well or not growing very well. Like it helps us to see like if the plant need to be like we need to add some fertilizers or some other stuff to make them develop very fast. So it's very uh, good application where we use drones or satellite to measure the high uh, the growing patterns of the plants. So the other application is estimating crop yields. And as you see at the picture, like sometimes if you want to guess how many apple you will have, so this type of sensors, drones, and satellite can give you an idea about it. So if you want to guess how many crops you will have at the 2 years, like at the coming 2 years, or how many you will get in 2 months. So by using drones and satellite, it can get you can figure out how much we are going to get when it's time to harvest. So this is a very good thing because it helps us to plan things better and not waste anything. So that's a very good powerful application of agriculture using drone and satellites. So usually when we are doing this type of application, like what we need is to capture the image. So capturing the image of satellite and drones with probably sometime equipped with specialized sensors that can be a multispectral uh, imaging or hyperspectral image, which is collecting some bands, so that make the image very powerful. But also we need to process the data. So after capturing the image, and then we need to process, analyze using some specialized software. Those software can be ArcGIS, QGIS, Envive, some package from Python, and some package from R. So Basically, this software extracts relevant information from the image. So, such as like we have vegetation indices, which indicate the amount of healthy green vegetation present. So we will stick a little bit about this word about the vegetation indices. I mean, yeah, because vegetation indices is a very important concept in agriculture. So we have uh, basically it's a mathematical combination of two or more spectral bands derived from satellite, and this is it's based on the principle of that the health green vegetation reflects more light in the near infrared region of the electromagnetic spectrum. So why that? Because like the chlorophyll, the pigment that give plant the green color absorb strongly in the red region and reflect strongly in the near infrared region. So some of the common vegetation indices are called like we have, for example, the NDVI, which is called normalized difference vegetation index. As you can see, the relationship we have the near infrared region where we reduce the reflectance and we divide by the near infrared region plus the reflectance. The interpretation of the NDVI is very straightforward. So wherever the NDVI like mm, is close to one, it indicates that the vegetation is very healthy. Is health. If is far from one, I mean like is near to -1, that means the vegetation is bad. Is poor vegetation. Apart from the NDVI, we have some others vegetation indices, just such as soil adjust vegetation index (SAVI). So SAVI is just an extension of NDVI and is designed to be less sensitive to soil effects. So the calculation is as follow. We have the same formula, but we have a new variables L. So L is just a soil brightness correction factor. So the value of L is typically range from 0 to 1. So this make this formula more accurate than a little bit like more sensitive to soil effect. We have also enhanced vegetation index EVI. So EVI is just another extension of NDVI. As you can see, both relationship are just an extension of NDVI. So NDVI is the commonly used vegetation indices. So for this type of vegetation indices, we have a B variables, which is the blue band reflectance, and this vegetation indices have been used for different examples. For example, for NASA MODIS satellite, which has which measure reflectance in 36 spectral bands. So it has been used to monitor global vegetation health and estimate crop yields, and also tracking deforestation. We have also a Landsat satellites. So the Landsat satellite sensors that carry like 9 spectral bands, including several that are used to calculate vegetation indices. So this satellite have been used to many variety of to many application, including monitoring the land use and mapping deforestation and so on. So as you know, collecting data is like gathering information in our case is like the data we get from the satellite and drones. So because we are talking about the satellite and drones, so when we are talking about data is the image we get from the satellite and drones. So but here the things is just having all this data is like having a puzzles. So you need to put them together to see the big picture. So actually collecting the data is just the beginning. The other things is the interpretation. Now, what's really important is understanding what all that data is trying to tell us. It's like you are reading a book and you don't just see the word on the pages, but you try to understand the story behind. Similarly, we need to interpret our data to find what is saying about our crops. So why is important? Because this help us to figure out what's working and what need to change. So of course we need to interpret our data. So the next things after interpreting our data is to make a decision. So once we've collected and interpreted all this data, we use it to make important decision about our farms. It's like having a roadmap, and we know where we are, where we want to go, and how to get there. this data helps us be smart farmers, making choices that help our uh, our crops grows better and our farms to be more efficient. So in conclusion, like sensing technology are truly transforming the world of agriculture. They empower farmers with data driving decision, making farmer more sustainable, efficient, and productive. So as we move forward, the integration of these technologies will undoubtedly play a pivotal role in shaping the future of agriculture. So we will see a little small examples. We don't have a lot of time, but we try to see how we can download our satellite image and how to process the satellite image to work with uh, some data to see how we can manage to get the vegetation indices more precisely in DVI. Well, this is the website where we can find data from satellite image. It's called Earth Explorer US Gov, but you can find many others. So how it works is here we have a we can specify the address in place. So for me, because I'm living in Senegal right now, I will just put Senegal. So when I click on show, I can see Senegal with latitude longitude. So I need just to click on it, and then you have Senegal. So you can use map to see the where Senegal is actually. I can reduce it because this is not all Senegal, of course. So what I need is just a simple example of Senegal, and this is enough. For I just need now to find out like because we, as I said, if you want to find NDVI, so you should find the time of where the crop is growing. So when everything's green. Otherwise, if we didn't find that moment, the NDVI will be very far from one, so it will be near to -1. And if it's near to -1, is a bad NDVI, so the vegetation will be very bad. So, like usually, what happens when you are doing this kind of job, you should know the area where you are. You should know when the crop is growing and when the crop is at the stage of like green. So that's very important. So here we just try to guess because it's just a simple example. So actually we don't need all because in Senegal actually the raining season is between June to September. So we choose September because we think that on September like everything's little bit green. But let's see because and in some part of the Senegal, so it's very hard to find people doing farming is especially near to the capital part and where I'm living actually. So after doing this, you can set the data and choose different satellite you want to use. Actually, we have a different satellite. I talk about the Landsat here. The Landsat is here, which is a very powerful satellite to get the band. So we're going to use the Landsat satellite and we use the Landsat 89 bands and we show the result. When showing the result is going to take a small time because I don't have a very fast internet, but you might see different, yes, actually we can see different uh, map from different season. So actually we can see here this part of the uh, place is a little bit is very green actually. We have another part, so we can keep doing it to find best place of Senegal. So we can because there's a lot of things we can find the second pages and see what we're gonna have and so on. So after you find your the suitable place you want to download, so the next things is to just like you just click here download and you will get all the information you need to download. Actually, I already have the data I want to download, so I don't want to do it. I just want to show you the website and how to find satellite data freely. And I just want to precise that if you want to open download the satellite image, you have to register in this website. So to get freely is free, of course, even though we have some part we need to pay, but most of the you can find whatever you need here freely. So I have issues with my internet right now, so I already download one. I'm gonna just move forward and to show you how to use this this image. So we can see here we have different type of imaging, satellite imaging. So let's move forward, and I will. So so this is uh, the file I just download from the website I just showed. So you can see that different map are here. So what we're gonna do now, we're gonna import this to our app. This app we're gonna use is called ArcMap, so which is a powerful software for handling for using satellite imaging. So we just need to be to click on data management tools, and here we find raster, and we click on raster processing and composite bands. So from composite bands we just need to take all the imaging with satellite imaging. So for doing that we just need to click here, and actually the software is taking more time, probably is due to yes, it's coming right now. So I'm just clicking at this file. This file is the file I downloaded from the website, as I said. So I just select this B1, B2, B3, B means the bands, because in order to know much information you need to take the bands. So it's not only satellite imaging, but it has also some information about the bands and uh, spectral bands. Yeah, usually it's the spectral bands, the near infrared bands, so which is very important. So I just need to add this part, so it will show up in this part. Probably you will see the band showing in this part. It will take this more little bit time because it's very heavy files. Yeah, and then here we just need to click OK, and the things will charge executing the composite band. So actually it's taking smallly. It can take some times, of course, because it's very heavy folders, very heavy files. And well, so the the composite band is ready now, completed. We just need, you can see here what we have downloaded. We have the band 1, 2, 3. So we have red, green, blue color, so which is very important. So we can click on it, and then probably we can change the. We have 7 band. We can choose from 5, 4 and 3. So this is the Senegal map. Actually, you can see the Dakar. Actually, we are living here. So what we're going to do now, we can download a shape, Senegal shape files district. Like we are here, we are not inside district, but we can go to Google, for example. We tap Google. You just need to put Senegal region shape files here, and you can download it. So I already did it, and normally you should find something like this. So uh, you might find something like this. So it comport all the Senegal region. So let me show you how it look like. Let me show you how it look like. It's just like the very, yes, it's something like that. So you will see all the regions, the boundary of the region. So this is what we call the shape file of Senegal. So usually it's just a boundary uh, with name of different places, region, or if it's district, is district. So I already download one. So what I'm going to do now is I'm just gonna export it. I'm gonna just add it by clicking here and find it out like here. So I just click on it. I just export this too. So you will find it out right now. You can see here this is the Senegal map actually. Let me reduce the size. It's a very big actually. Yes, this is Senegal map, and this is the satellite image. So what I'm going to do now is just to change this to hollow to make it like visible in order to us to see. Change this one to hollow also. It help us to see that the mismatch. So this is the satellite image. This is the Senegal shape file I downloaded. So now it's together. You can see that the part of the satellite image I have downloaded is the part of where I'm living is the Dakar chess and also other parts. So what we can do now is to show the name of the different place. So we can show the name of different place by clicking at the shape files limit department, and yeah, here we can show the labels, and we can click here, we can check the labels features, and we apply. Okay, so here we can see all the names of Senegal, like is department, because Senegal we have region and department is included inside region. So we can see here the place actually is Mbour, Thiès, Tivaouane. This is my region right now. This is the capital of Senegal, Dakar, and this is the information of the satellite I've exported, and I just uh, superposed together to have a good visibility of these things. So the other things we can do with this image is we can specify the area we want to work. So if you want to specify the area you want to work, for example, if I want to work with this area called uh, chess, I can just click on it here. So it emphasize this part. So after that, I just need to click here on the region and then export it, the data, export the data, so that it will create a only chess shapefile. So what I'm doing is just extract the place I want to work. I want to only work with chess. So I'll just put chess, and then I will click on OK. So it changes yes. So you can see now we see the place I would like to work on is only this part. So this region is called chess. Of course, why it's called chess is because one of the department of the region is called chess, which is the main department, and we have other department Bur and Tiwawa. So it's near to the capital city. So this is the Atlantic Ocean, which is at the border. So basically, we can do this, and so so basically, what you can do actually is to extract this part. So in order to do that, we just need to come at the spatial analyst tools. We click here on it, and we see extraction, and then we want to extract by the mask. So we click on it, and we input the raster, which is the file we get. We input the feature mask data, which is the chess region. Yeah, it's like that, and then we click OK. So we wait some moment, and we create our new extract file, the file we extract by mask, which is visible. We see it visible at this part. So actually we have to wait a small moment because it will take time. Yeah, so basically we just extract this part of the in our map. Yeah, now it's over. We have the extract part, so which is here. So what we can do right now is we can select this one and see. If we just deselect this one, we can also do the same. We can change the variables to 5 and 4 and 3, uh, which is here, and then we can select here. So right now we doesn't need this one, because if you have this, you just have the 5. We can also deselect. You can also change this one to hollow in order to make it visible. Right now it's clear. Now we can see the satellite part with the region we extract. The region we extract is the chess region with our own chess Mbur. So that's amazing things we can do, which is very powerful things. Another things we can do with this is image classification. We can classify different things inside this region, but right now it's very difficult. But we can do an examples. But normally, before doing the classification, you should like check the map very well to see what you really want to classify. If you want to classify the farm to the living area, or you want to classify the mountain vegetation parts, it's very important to know this before doing any job of classification. But we will try with a simple example right now, to see. So what you can do actually is you can classify the things. You can find out what is what in here. For example, here we have, for example, we have the map here. We can, if we know this is, for example, a living area, you can like put the marking and then do the what we call the subsampling to get different samples. You can get different samples if you know the area. But if you don't know the area, you can also do the unsupervised classification. You do like that, and you specify the band you want to classify, which is this one, and then I click on this one. And you also need to specify the number of class. Here I say 4 classes, and yes, I just put OK, and the things will run up. So normally you see the classification, unsupervised classification of the map. So, but if you know the different elements, the living area, the farming, or the things you want to classify, you can by yourself specify that and use different algorithm, random forest, SVR, and other algorithms, which is very powerful tools. So basically, it's like that. So actually, I finished the classification. I used four classes. One you can see here, 1, 2, 3, 4, and the map has been automatically classified. This is the unsupervised classification because cannot really get the information about what is what actually. But if it's unsupervised classification, it means like the blue area and different color area means something. Probably I can say that the green one is the living area. Yeah, the green one should be probably the living area. So, and the blue probably is the water, and the red part can be the vegetation or something like that. So other things we can do when we have the map is to calculate the NDVI. So I think that's most important. If how to get the NDVI, if you get the NDVI, you can do many things with that values of NDVI. So for the NDVI, you just need to come here, Windows Image Analysis, and you click on uh, the data you want to calculate the NDVI, which is the one you classify actually, and then it's actually processing. It takes some time to run, so we can also precise here the bands you wanna use. Okay, and then you can deselect everything and then select one. It will take some moment in before to come, so let's wait and see. Well, the things is taking time. Probably it's because there's a lot of cluster we have used. So let's just make it the things by ourselves. Let's just uh, randomly take some image uh, where we create our image, where we create our classification by ourselves. So usually what we get is here. So let me delete these things. This is the clustering things. Let me delete again. We back from our initial data. So this is what we get, and what we're gonna do is we just take this and we draw here like this one. We create the samples, different samples for the class we are creating now. To and yes, I think basically it's like that. It's enough. It's just an explanation. Then we can combine these five. We combine them. We change the name. We call it like living area. We save. We can change the color uh to this color. It's pink, right? Yes. And then we can do the same with the water. We can do the same with the water actually. I think this place is water. We can just click on it. Yes, and you can go through it. So you can see some water here, and actually it's very hard for to work on this because you might not see like any farming area. It's very hard to find a farming area. It's like yes, I think this is a farming area. This place is a farming area. So let's see like let's just group this first to water. So we just need to group this. Let's see this is the water, and then we select. So we keep doing the same things. So let's say this is the our let's say this is the green for the framing area, the crop area. It's normal that we cannot see many crop area because the place I didn't take a good place for the examples. The place am located is not a framing region, so it's more close to the capital and mostly is for tourism and all those things. So I think this is enough. We can take this and we group this. We can say that is crop is crop. So after that, we just need to save the files. So we can call it like mm, examples that shape, and then we save the files. So the next step is to open the segmentation and classification part. Here you can see we can train using SQL vector machine, using random tree, and yeah, we can even export the data for deep learning. If you want to use deep learning, you can export the training data for deep learning. So we're going to just use the model we have here. We're going to use the SQL vector machine, and we put the raster. We put the training sample features we have. So uh, this is this should be the file we create right now. I don't know where did I put the file we create right now, but it should be here. Yes, this example for that one, and then we say okay. So right now it's not working. It's stop processing. I don't know why. And yes, this is the example. This is the output. Okay, it's a failed. Okay, yes. So I didn't choose the right raster file. Should be the original file we have. So basically it's like it's over right now, so it's just over, so we can check the result. We can check the result, so the result should appear here. It's not coming yet. It's a little bit slow because of course like I'm right now opening lot of windows. So yeah, basically this is what we are getting from the classification. It's not really real actually because we didn't put samples. The samples we are choosing is very small, so you can see like all this yellow area is living area. Only small part is crop, and this is water area. So actually, it's I think for the living area, you should have some place which is not having any living area. So probably it's empty area, and yeah, so on is that's is actually is most of it is like that. So after we get the classification, let's try if we can find the ndvi. So we try again to see if we can get the ndvi data. So let's see if it's possible to get the NDVI information. So these things may take some time because again, the NDVI data is also depend to the number of crop area. But right now, I can see that there's only few crop areas, so most of the area are living areas. So I don't think we find a good NDVA values. But let's see what we're gonna get from these examples. Now we can calculate the NDVI from the extracted values. Well, this is the NDVI values. So you can see the lowest is 0, the highest is 0.5. Actually, it's not very good NDVI values because it's a little bit from 0 to 1. Probably it's because the map inside the map there are very small values of small area of crops. So because the NDVA values is mostly for green, as I explained at the PPT part. So that's all. So now we know how to do simple classification and to find the NDVA values of the crops using a satellite image. So that's all for this session. Thank you for attending. And if you have any question, feel free to ask. Thank you very much. And uh, I'm waiting for any suggestion or any question you may have. Thank you.